Hi, I'm Dieter. I'm a solution engineer at DataStax. Today, I'm going to walk you through a demo. We are implementing a chatbot application that is powered by Astra DB and Langflow. Langflow is a low-code environment. It allows you to implement any kind of LLM-powered application in the fraction of time as it would require to do that with one of these code-based frameworks. In Langflow, simplicity and flexibility is baked into Langflow. We simply drag and drop components into a canvas and connect these components with each other to define flows. For the chatbot application that we implement today, we define two flows, a vectorization flow and a chat flow. The vectorization flow takes PDF documents as input, vectorizes them, and stores the context in Astra DB, our vector store. The chat flow takes a question as input, retrieves context out of Astra DB, our vector store, and provides context and question to the LLM. So this allows the LLM to answer questions on point and not to hallucinate. And what we do here has a name. So we leverage RAG, retrieval augmented generation. So this is a pattern that you want to use whenever you implement a chatbot that answers questions based on your private data. This is the Langflow UI. On the left-hand side, we have the menu, and there we have all the components we need to define or implement LLM-powered application. And as you can see, there is also quite some choice. So under models, we have a number of large language models that we can use in our flow. So this also allows us to experiment, to see, so what is the difference using the large language model A compared with large language model B? And it's super simple to exchange these components with each other. So I would like to walk you through the flow in front of us. So this is the vectorization flow. It starts with a file component. The file component has a PDF as input. This PDF document flows into the recursive character text splitter document. As you can see, the components, they have input fields. So we can specify some properties that are important. And for this text splitting component, the chunk size is important and the overlap of these chunk sizes. The component takes the PDF, splits the PDF into chunks, and then these chunks flow through our embedding model. In this case, we leverage OpenAI embedding model, the ADA model. We need to also provide some input properties like the API key. So this embedding model vectorizes the chunk, and then we have the Astra DB component that stores the chunk, the text chunk, the context side by side with the embedding. And so this is not only about graphical components, that is actually a flow that is executable. So by clicking here in the right upper corner of the component, we execute the whole flow. And green check mark means that the flow is valid and works. And actually we stored right now, by executing that flow, all this context in Astra DB. This is the Astra DB UI, and there we have databases. Database has collections, and for our chatbot, we use the Langflow collection. So all that context that we provided as input for the vectorization flow ends up in the Langflow collection. And as you can see, we have more than 1,000 records. Each record contains the text chunk and the embedding vector side by side, as you can see here. So content, so that is the text chunk, and the vector is the embedding for that text chunk. And we are going to leverage that for similarity search later in the chat flow. Let's go back to Langflow. This is the chat flow. It starts with a chat input component. The question goes into that component. It flows through the embedding model to get vectorized. The vector is used in the Astra DB search component as a query parameter in order to find the context that is most similar with our question. The context and the question flows into a prompt, and the prompt flows into the large language model. And with this, there is everything in place so that the LLM is able to answer the question on point and not to hallucinate. Let me show you how simple it is to drag and drop these components into the canvas and to connect these components with each other. So now we have a chat output component. And like we did before, so we can also execute that flow in order to check that the flow is valid. As soon as the flow is valid, we can even run the whole flow in combination with a conversational UI like this. So we can ask questions and retrieve an answer from the LLM based on the context that was retrieved out of Astra DB. That is super nice and that is super simple, but wouldn't it be nice to leverage these flows in our own application? So let's implement our own chatbot user interface and use these flows within our application. So let me show you how that works. Here is the development environment, and there is a Python script. And this Python script, it is just about Streamlit chat UI. It is about input fields. It is about output fields to draw the answer. But there is nothing about large language models, about vector stores. Now let's integrate the flow into that application. And it is as simple as that. So within Langflow, there is the API button, and then there are a number of tabs available. For this integration, for that demo, I want to leverage the Python code-based integration. And within that tab, we see everything that we need to copy and paste into our application to have that flow embedded in our Streamlit application. So as you can see, there is an import required. There are some tweaks to tweak these components. You have seen in the canvas, in the UI, that all these components have their input fields. And with these tweaks, you actually can specify these properties. And then finally, there is the function that we need to integrate into our Python code. So this is the flow, and this flow requires, the flow. The flow is something that we can export into a JSON file, and we reference that JSON file within our application. And then we have to provide the question and the tweak structure. So let me show you how that looks like within our development environment. So here is the import, and then there is the definition of the tweaks. So I added the OpenAI API key for that demo, and I also worked on the prompt a bit to tell the LLM about the role, the expectation, what the LLM should do. And as you can see, there are some placeholders for the context and the question. And then the flow is executed directly here. Round flow from JSON requires our flow that was exported as a JSON file, then the question, and then the tweak structure. And with all that, we have a full-blown RAG chatbot implemented. This is how the RAG chatbot looks like when we run the Streamlit application. Let's ask, what were the two main things the author worked on before college? As said before, so this application is a full-blown RAG application. There is nothing about vector stores, about LLMs within the application code. This is all embedded and integrated via the RAG function, via the function that we execute. With this, many thanks for your interest in understanding what Langflow is. And yeah, looking forward to dig deeper into details if there are any questions.